NextStrain provides a resource so that you can look at the evolution of viruses around the world. Now I've opened the page on COVID because that's the one I want to look at. So here you can see that the screen's broken down into three sections in the grid. So first you have the phylogenetic tree, which is here. Second, you have a map where you have pie charts which show the number of cases of each of the different types in those particular locations. Below this there's a chart showing where all the mutations occur, where the most diverse regions are. So if you see here is most of these peaks, which is in the S protein, and then below you can see the prevalence of each of the different varieties. So to start with, we had the grey ones, and then the alphas, and those made up the percentage. And then as we go along, then you've seen that Delta took over, and then Omicron, and then this second subgroup of Omicron. Now the thing you want to find out about is the rate of evolution. Now the rate of evolution is going to depend on a number of things. It's going to depend on the amount of cases there are, so the amount of the size of the population that can undergo mutation, and there might be some evidence for different rates of mutation in different parts of the tree. So for example, this bit the orange bit might be mutating more rapidly, or the blue bit, I mean, you can't completely say. Now, mutation assumes a molecular clock. So the way you display the mutation and molecular clock data, so how fast it's mutating, is by looking at the clock plot. So what that does is it creates a regression line showing the number of changes for each of those different variants. So if you look, you can see that most of the blue ones sit on the line. The orange ones, and particularly the bright orange ones, are above the line, and this tells you that you've got a faster rate of evolution happening in those particular subgroups. Now that could be an example of what is called punctuated evolution. So punctuated evolution means you have a steady molecular clock change, then evolution hits upon some sort of exciting new invention, so for example multicellular organisms from single cellular organisms, and then you get a rapid expansion because it goes into new niches and new opportunities. So this looks like the orange variety, the Omicron, the first one, was evolving rapidly to fit a new environment, and that the darker orange, or possibly close to red one, is evolving even more rapidly and more distantly from the regular orange to fit with the new environment. Now the rise of Omicron corresponds with August last year, 2021, to January now. So this corresponds to the period where we were fully vaccinated. So this looks like a vaccine response which has changed the slope of the rate estimate. So the rate estimate in total is 24.758 subunits. Now if I go back to the rectangular view and display the data as normal, and then I click on the Omicron clade, so I just get this clade rather than everything, so I'm just split it down into the light oranges and the dark oranges. Now if I click on clock for this, it's showing the regular line, and looking here, they're all very clearly above that. And there's one down here that's below. But that suggests that what you need to do is calculate a different rate for this particular clade. That you can't do in NextStrain, but we can do using other tools. But NextStrain gives you a background estimate of what the substitution rate is, and then we can use other methods to look at the variation in substitution rates in specific parts of the evolutionary tree of COVID.